Hello, today we'll be doing a simple image classifier in machine learning, and this classifier is going to be really simple. We are just going to be classifying some images that the classifier would be able to tell if it's an image that was taken during the day or if it's an image that was taken during the nighttime. And this is the steps that we'll be taking to get the classifier up and running. This first function here is a function that actually gets all the images from my directory that they are stored in. There are a bunch of night images and a bunch of day images, and this function will get the image. It will go into the image directory, and the first directory would be the day directory. It will grab those images, it will grab all the images in there, and then you can see it's in a for loop. So it grabs all those images and it goes back and it goes into the nighttime directory, and it grabs all the images in the night directory. This is all from, these are standard libraries that are available to us in Python. We're importing the operating system library, the glob library, and this matplotlib to do our image, to grab images and stuff like that. And this function also not only grabs the images, but it takes these and makes the image, each image, into a category. So it will have the day category and the nighttime category. So we're going to end up with a tuple with the image and the image category or image type. And as usual, we get the resources we need. These are the resources we're going to be needing. OpenCV for computer vision, this computer vision library, NumPy operating on images, and matplotlib, PLT for drawing images to the screen. We will be displaying our images in line inside of a notebook. Alright, so here we get the directory. This is the directory that contains the images. This is the actual directory that contains the images. Alright, and we pass that directory to our load data set, that first function that I explained earlier. All right, once we get the images are loaded into image list. Once we have the images, we have to standardize the images. I'm assuming that all the images are of different dimensions, X and Y dimension. So we have to standardize all the images, make them one consistent dimension or size. And these are the steps we're going to do. We're going to standardize the input, and we're going to standardize the output label. So we're going to, instead of using a categorical label, day, night, we are going to convert that into a numerical label, because numerical labels are better capable of you can do operations on them. They're a little easier to handle. All right. This is the standardization method. We're going to standardize each image using this method here. We are going to turn them into, we're going to resize all image to an 11 by 600 image. All right, now we're standardizing the output label. This just encodes, if it's a day label, we make it 1, otherwise it will be 0. So for daytime, we're going to make those have a label of 1, and for nighttime, we'll have a numerical label of 0. All right, this is the standardizing function. This function will take the raw data list and coordinate the standardization process. It will return the final list. Okay, so this just takes the it list and it just basically hands the images to the image function right here, and hands all of the labels to the labeling function for standardization purposes. And it just reintegrates the image, the standardized image, with its corresponding label, and makes what we call a standardized list. All right, let's construct the standardized list here. This is how we construct the list. We just and we're gonna send our image list that we created above to the standardize method, and that will coordinate the standardization for us. Let's visually verify the images have been converted successfully. Now, right, so we just pull out one of the image. It's 3-dimensional. It's a list of tuples. So this the image number will represent the row, and the second value here would represent the column of interest. So the first column will be the images, and the second column will be the labels. Hope you understand 2-dimensional list work. I'm not going to be going into that here. All right, let's clear all the outputs and actually go through each one. All right, so we're going through each one. Here we will get the image. That's the image that it brought up. So we can change this and see what image number 1 will bring up for us. Let's see what that image will look like. It's another image, another day image. And image number 2, let's see what that looks like. Is that the same image? Something. Well, some of these photos are repeating. Let's see, number 5. Yeah. So what happened is they, for the sake of to be efficient, they just repeated some of these images. They probably tweaked the images a little bit, reduced the intensity and the shading, the tint, that kind of thing. Let's see what image 10 is about. All right, that's another day image. All right, let's look at a night image. The night images start, I believe, at 44, 45, something like that. I have 45 images each, I think. So this is a night image. All right, 50. Night image, and you can see the label here. It's another night image, so the label is 0, and the dimensions are what we expect they should be. That's what we changed every single image to. Let's do image 88 and see what that is. It's another night image, and you can see here it's been standardized successfully. Don't worry about the color depth. I mean, we have to worry about it, but we will be using it. And nighttime image here. All right, so let's move on. We're going into the feature extraction. In this example, we will be using the brightness feature in the image to do the classification. So all the intensity in the image is probably a good way of classifying these images. So we'll pick that as our feature. All right, it's really simple. All we do is we're gonna just calculate the average brightness of each image to classify the image. So you would expect a daytime image to have an average brightness higher than a nighttime image. We will be using the HSV color space technique as part of the process. So the HSV color space will help us to sort of get some good, even grayscale images. When you're calculating based on intensity, grayscale images are the way to go. So the first step, we'll convert an RGB image to HSV. So we're going to just look at an example of what we're going to do here. So let's convert that. We're using image number 0 first. We get the image that we want. Then we use this conversion method that's available in OpenCV. This is CVT color, right? In here you get the test image that we'll be working with and the color, whatever it does. All right. This test image is from this image above. I'm not sure, where's that image from? Let's see. All right, we converted the image. We got test image. Oh, here it is. Sorry. Here it is, test image. That's the test image there. We got a label of 1, so it's a daytime image. We know it's a daytime image. So let's look at the color channels. We separate the HSV into its respective channels. Here, so channel 0, channel 1, and channel 2. Now we're going to display our HSV images. All right, this is how you display them in a strip. So we're displaying them in a strip. This is the original image, the standardized image. This is the H channel. Up here, you see the H channel. This is the S channel, and this is the V channel. And you can see that in the V channel, the intensity is what you want to see for a daytime image. So we're definitely using the intensity in that grayscale image in the V channel. That's what we're going to be using to do our classification. And that's why it was important to convert the RGB image to a HSV image. All right, so you can you broke out the channels, and now we can use the V channel to do the classification. All right, this function calculates the average brightness of the images. So it receives the image. Okay, it receives it in RGB, then it converts it to the HSV color channels. HSV, and we're using, okay, it's converted to HSV, and here you can see we'll be using the HSV2, that is the V channel. We will be using that photo, the V channel photo. All right, and we'll be summing up, use the sum function to sum up the intensity of the pixels, and we get the average by dividing it by the area of the image, right? The area is what we had from before. That's all standardized image are of this dimension, and the area is just 600 by 1100, and that gives us our. Then we take the average by dividing the sum of the brightness over the area. All right, and that's how we get the average intensity of the photo. All right, we're gonna give it a spin, that function above. Oof. And we see here, we send it image 54, image number 54. We get that image out from our standardized list, take that image out. We send it to the average brightness function, and it gave us this nighttime image has an average brightness of 87. All right, let's see what a daytime image would look like. Let's do this let's do a daytime image and see what the average intensity is. And you can see the average intensity is high, much higher. In this case, for this daytime image, it's 157. So this is a good way of classifying night and day pictures. It's a simple classifier, just by using simple arithmetic. All right, we'll move on to the next function. This function just gives us the range. So it goes through each image. It will know whether it's a day image or a night image based on the label of the image. Based on the label, it'll know whether it's a day image or night image. If it's a day image, it would calculate the average intensity, and it will save that number in the lower day and upper day. So we're working out the range. We're just working out the range here. So we want the lowest day range and the highest day range. So we'll be using that number to tweak our classifier. And the same thing with the night value. We want the lowest night range and the highest night range. All right. And here, when we work it out, we see that the day range ranges between 98.89 and 200. Right, we have 45 images here, and the night range ranges from 8.24 all the way up to about 98.99. You can see that there will be some slight error. See, this 98.89 is a bit less than this 98.99, so we're going to have a slight error. No classifier is perfect, so we're just going to have a slight error. We may have a classifier that may be 96% correct. All right, we'll have to live with that. And this is the classifier here. So basically, based on these ranges, we can just tweak this number. So if the average is, let's say if the average is above 98.89, if the average is above that, we just classify it as a day. Right? We'll take that hit with the nighttime. We'll take that small percentage of hit. And or else it will be a night picture. So that's, see how simple the classifier is. Once it's all said and done, we worked out basically this would be the training information that we're using. You know, I'm kind of stepping through this manually. This is This is the training information. So from the training, we've worked out these ranges, basically. And I only have 45, I only have 91 photos. Probably would do a better job if I had 1,000 photos or something like that, 1,000 images to work with. Probably do a better job, get a better, more accurate classifier. But that's basically how you go about classifying images. A simple classifier, day, night classifier. And that's how it's done. Thank you. Bye.